Good day everyone. So welcome to another video on our channel Tandy Science. So today we're going to talk about a topic that you are supposed to know if you are doing grade 10 physical sciences. And the main heading for that, or the main topic, is quantitative aspects of chemical change. Like I said, it's grade 10 physical sciences. I'm going to do a number of videos on this topic, and this is just the first of the many. Try to go to the next slide. Okay, so I want you to think of this scenario over here. Imagine that you took a grain of salt or sugar, and then we're able to zoom into that grain or that crystal of sugar or salt, right? Maybe you had a very large microscope that you are able to see inside it. What you would see is something like this. So you would see a number of atoms sitting and arranged in a specific way that is specific to the material. And you see that it's a lot of materials that you are looking at. It's a lot of atoms that you are actually looking at. Too many to count. And essentially this idea that there's so many particles even in the smallest amount of a material leads us to a concept that we describe as the mole. So it's important for you to understand what we mean when we talk about the mole, because you're going to use it a lot in the when we in the next during this term if you're doing grade 10, right? So how do we define the mole? In chemistry, we describe a mole of particle as an amount of, you see this very large number that I cannot even pronounce. So when we talk about 1 mole, we mean that literally in that substance, so we can say there's 1 mole of carbon. It means there is this many, you see how many zeros there is there? There's a lot of zeros there, particles. So when we talk about particles, we can mean that maybe there's this number of atoms, or there's this number of molecules, or there's this number of compounds. So I want you to understand that it's not just limited to atoms. We can define a mole for atoms or molecules or compounds, etc., etc. So any amount of particle, when that a mole contains this amount, but of course you're not always gonna write this number. So imagine it's like saying, instead of saying 12 eggs, you say it's a dozen. So it's a way to, a mole is a way to describe this very long number. And normally this number, now written in scientific notation, we call it Avogadro's number. So 1 mole is equals to those many particles. And now I'm writing it in scientific notation because it'll take you forever to write this long number. So you say Avogadro's number, which is called Na, equals to 6,023. Sometimes there's a 3 depending on the number of decimal places after the comma, multiply by 10 to the power of 23. So this is a number that you should be familiar with. And we use Avogadro's number and the mole in chemistry to help us quantify what happens in chemical reactions. So in chemical reactions, you'll normally see they'll say 1 mole of this, 2 moles of that, 0.5 mole of this. They are talking about this number, right? Okay, so let's look at a few examples to further explain this concept of a mole. So if you look at your periodic table, there's a compound, carbon, right? And you see this value there, we call it its relative atomic mass. So if we took a scale where you can weigh something, and we measured exactly 12 grams of carbon, it would mean that 12 gram of carbon is actually equals to 1 mole. And we know that 1 mole is equals to 6.02 multiplied by 10 to the power of 23 particles. But in this case, we know which particles we are dealing with. We are dealing with carbon atoms, right? So that 12 gram of carbon equals to 1 mole of carbon atoms, or 6.02 multiplied by 10 to the power of 23 carbon atoms. This is the same thing for any element in your periodic table. So you see, if copper, the relative atomic mass is 63.546. So if you measured 63 gram of carbon, you would have 1 mole, or this number 6.02 multiplied by 10 to the power of 23 copper atoms, right? So if you measured 63.5, you would have 1 mole of copper atoms. So this is essentially, if you measure the relative atomic mass of any element, let me go back. So this is the relative atomic mass. If you measure it for any element of the periodic table, we have 1 mole of that element. If that is not clear, let us look at this table here. So if you look at your periodic table, hydrogen has a relative atomic mass of 1,01. Now, if you were to take a scale and you weigh at least exactly 1.01 grams of hydrogen, we would know that you have 1 mole of hydrogen. The same thing, if you look at the relative atomic mass of magnesium, and then you measure on your scale, they say this is magnesium, then you take it to your scale, you weigh it, and it says that it's 24.3 grams. You know that it's 1 mole. However, look at this. We know the relative atomic mass of carbon is 12, but now you are given a sample, you weigh it, and you find that that sample of carbon that contains carbon atoms is 24 grams. What does that mean? It means that it's actually 2 moles of carbon, because we know 1 mole of carbon would be equal to 12 grams. Even with chlorine, its relative atomic mass is 34.5. However, you weigh 70.9. This number is double this number. It means that you actually have 2 moles. Here, the relative atomic mass of nitrogen is 14. If you now, but then when you measure that sample that's given to you, see it gives you 42 grams. It means that there's actually 3 moles of nitrogen in whatever sample that you have requested to weigh, right? So there are certain equations that we can use to calculate number of moles, the mass, and something that we call the molar mass, right? So N here means the number of moles, and it's measured in mole. M is called the molar mass, and it's measured in grams per mole. Then we also have small letter m, which is the mass of your substance. It's measured in grams. So familiarize yourself with this triangle. It's pretty popular. So it means that if I want to calculate the number of moles, N, I need to know the mass of my sample as well as the molar mass of my sample. So the relative atomic mass is actually your molar mass. Let me go back. So the molar mass of hydrogen would be 1,0 grams per mole. The molar mass of magnesium would be 24.3 grams per mole. The molar mass of carbon would be 12 grams. I think now you understand. Okay, however, let's say I wanted to find the mass. If I want to find the mass, I need to know the number of moles, right? As well as the molar mass, and multiply the two. If I now want to calculate the molar mass, which is big letter M, I need to have the mass divided by the number of moles, right? So you see, so it says N equals to M divided, hence there's a divider by M. But M equals to N multiplied by M. And this big letter M equals to M divided by N. Hope that is clear. So we can further explore this idea, right? And we say, okay, let's say you have magnesium. We know its relative atomic mass is 24.3. That essentially also means that its molar mass is 24.3 grams per mole. So it's per mole because you see it's mole to the power of -1. It means it's per mole. And now we know that the mass of 1 mole of the element, so if you wanted to measure exactly 1 mole of magnesium, you will need to weigh 24.3 grams. Same thing can be said for lithium. Its relative atomic mass is 6.94. Its molar mass also is the same, is 69.94, and 1 mole of lithium will equal to 6.94 grams. So just look as well as oxygen. Relative atomic mass is 16. Molar mass of oxygen is also 16 grams per mole. 1 mole of oxygen, the mass of 1 mole of oxygen would be 16 grams. Relative atomic mass of nitrogen is equals to 14. Its molar mass is also equals to 14 grams per mole. And then 1 mole of the element, the mass of 1 mole of nitrogen would be equals to 14 grams. So those are the things that you need to understand. The same thing here with iron. Iron, its relative atomic mass is 55.8. Its molar mass is also 55.8 but grams per mole. And then the mass of 1 mole of iron equals to 55.8. Right? Okay, we would look at examples just now. Okay, like I said, we're going to look at a few examples that will include calculations. Okay, so let us look at a number of examples. For this, I would say you need a calculator so that you can do the calculations along with me. So I compiled a number of questions here. So the first question is straightforward. It says calculate the number of moles of iron in 111.7 grams of sample. So they went and they weighed 111.7 grams of iron, and we have to find how many moles are in that. So now if you remember just from this our slides, we know that if we have the mass, so we have the mass of iron, right? Iron MFE. They gave it to us and they said it is 111.7 grams. And then I know that I can look at my periodic table. So normally you are given a periodic table at the back of your question paper and find my molar mass, big letter M, my molar mass of iron. And if you look there, it's going to be sometimes they give you in a question, but if they don't, you just look at your and I've already described what molar mass is. You just look at your periodic table and you find that it's 55.85. Remember, this value is equals to the relative atomic mass of whatever respective element. So it's 55.85 grams per mole. It's going to be grams per mole. Okay, right? So now remember on our equations, so there's an equation that says the number of moles, we spoke about this, equals to small letter m divided by big letter M, capital letter M. So that's the mass here in grams, and this is the molar mass in grams per mole, right? So we say, oh, okay, I know my mass here, it's given. So I'm just going to write it is 111.7. Then you divide that value by M, big letter M, which is 55, right? 55.85. So it's going to be 55.85. if you put this value, so you can put this on the calculator. Let us try to do that. So you see there's a calculator over there. You say, okay, I have 111.7 and then divided by 55.85. And let's see how much is that. It's going to give you a value of 2. And you know that N, which is the number of moles, is measured in mole. So you can just write MOL and you have your answer. So it means that in 111.7 grams of iron, we have 2 moles. Okay, hope that was clear. So now let us look at the second question. So that was question 1. Let us look at question 2. So we'll go again and say, let's read the question. Here you have a sample that contains 5 moles of zinc. So now they give you the number of moles of the substance. A, what is the mass of the zinc in the sample? So they want the mass of the zinc. So you go back and say, oh, okay. What is it that I have? I have the number of moles of zinc. So I'll just write down N. See, okay, I have the number of moles of zinc. You don't have to write the Zn in the brackets. So you can just write the number of moles of zinc is 5. The number of moles, you just write mol, M-O-L. Okay, but what else do I know about zinc? I know that if I look at my periodic table, I can find the molar mass of zinc. So I'm just also going to write that down. So you writing down all the information that you know, that you understand, right? And if I look at my periodic table, which is provided to you at the back of your question paper, you can look for it in your textbook, or you can Google a periodic table. If you look at the relative atomic mass, you will see that I know that it's equal to the molar mass, but however the molar mass is now measured in grams per mole. Alright, so I have this, and I'm having to, let me see, what did the question say? I have to find the mass. Okay, it means that I have to find small letter m. So you say, okay, I know from my equations that we spoke about that the mass is going to just be the number of moles of zinc multiplied by the molar mass. So then from here I will get my mass in grams. So you say, okay, 5 multiplied by 65.39, right? And then we can put this whole expression on the calculator. Let me just clear this. So you have 5 multiplied by 65.9. Let's see how much is that. So you write that in decimal form. So how much is that? It is 329. Let me see, it was, so it's 65.39. No, that was a mistake. 65.39 over here. Okay, so let's fix that. So you say, okay, let me clear this. It's 5 multiplied by 65.39. There you are, and you get this value there, which is 326.95 grams. So always just double check. So this is measured in grams. Remember, you must include that it's measured in grams, right? Because you just calculated it, right? Awesome. So now let's go to the question. So that was question 2A. So that was question 2A. We need to go to question B. So question B, we need to calculate how many atoms are in the sample, how many zinc atoms are in the sample, right? So we say, okay, I know from what I've described that one mole, and in this case, we know that we are talking about, what is it? Let me actually do this. I don't want to write this in full. So you know that one mole, because I'm going to make it an equation. So you know that one mole of zinc equals to 6,02. So always check the value that is given. Is it 6,02 or 6,03 at the back of your calculator, at the back of your question paper, and write that there. So it depends on the number of decimal places. So you know that one mole of zinc will be equals to 6.02 multiplied by 10 zinc atoms. We want to find, how many zinc atoms are there? So we want to find how many zinc atoms are in 5 moles, because we know they said that they've given you 5, right? So we say, okay, 5 equals to now x, and we're just solving for x to find the number of atoms. One way to do this would be just to cross multiply. So I'll multiply the 1 by x. So if you multiply 1 by x, you will get x. Any number multiplied by 1 is that number. And then the same way, crossing 5 multiplied by 6.02 multiplied by 10 to the power of 23, you can just put that whole expression in your calculator, and that will actually now give you the number of zinc number of zinc atoms in 5 moles. Okay, so let's put this in a calculator. I'll move this a bit so clear that. So you say 5 multiplied by 6.02 multiplied by 10 to the power of 23. Then you say, okay, and you find that you get a value of 3,015. Is it 1015 or 3,01? It depends how many decimal places you are required to write. 3,01 multiplied by 10 to the power of 24. So this would mean that you then write down that, okay, I have the number of zinc atoms in this particular sample is 3,01 multiplied by 10 to the power of 24. So you have zinc, you can just write the zinc atoms. So you see now how we apply Avogadro's number there that we spoke about, right? Then let's go to question number 3. So question number 3 says, calculate the mass of 4.5. Calculate the mass of 4.5 multiplied by 10 to the power of 25 silicon atoms. So you say, okay, so the first thing that you need to do here is to find okay, I didn't realize that there's still so much space there, but it's fine. Is to find what you call now, is to find the number of moles. So how can we do that? So you say, okay, the same thing that we've done, 1 mole of silicon atoms is equals to 6,02 multiply by 10 to the power of 23. This is Avogadro's number. Remember, 1 mole of any particle is equals to this number of atoms or particles, and your particles can either be atoms. In this case, it is silicon atoms, right? But now I am given that for whatever sample that they are talking about, they actually had 4.5 silicon atoms. So you just say 4,5 multiply by 10 to the power of 10 with 5 to the power of 23. But I'm looking for the number of moles, so let me just write n there, and to find n I can just cross multiply. So I'll say n multiply by that, and then on this side of the equation I'll have n multiply by 6,02 multiply by 10 to the power of 23, which will now be equals to, on this side then I'll cross multiply 1 by multiply by 4.5. So you know any number multiplied by 1 is just going to be that number. So it means on the other side of my equation I'll have 4,5 multiply by 10 to the power of 23. Now you see that you have an equation like that. And then I have to solve for n. I will just divide both sides by 6.02, 6.02, so it's divide by 6.02 multiply by 10 to the power of 23, because you're trying to make n the subject of your formula, right? So it's going to be 23. So remember, what you do on the right, you must also do on the left. So even on this side, you must also now divide by 6,02 multiply by 10 to the power of 23. And then, okay, there you are. So essentially what this means is that here, this will cancel this, for 6.02 multiplied by 10 to the power of 22 divided by itself is just going to be 1. Then you're left with n. And this expression you can just put on their calculator. So you'll say, okay, let us have a look. Okay, so I will have 4.5, so 4.5 multiply by 10 to the power of 23, and the whole thing must be divided by 6,02 multiply by 10 to the power of 23. Then you say, all right, you write it in decimal form, so that is going to be something. I don't know why it looks like that. Did I make a mistake somewhere? Did I make a mistake anyway? Let's go. Oh, now, okay, it's actually 25. So here it's actually 25. No, that is fine. Here it's 23, but here it's actually 25. So hope you guys were able to catch that quickly. 25, even here, then you just write 25. But the numbers really don't matter. It's just for you to understand the, what do you call this, the steps, right? And always double check your answers. So you have 4.5 multiplied by 10 to the power of 25. The whole thing is divided by 6,02 multiplied by 10 to the power of 23. Let's see how much is that, and then you get a value of 74,75. And then you know, since it's the number of moles, you must write more. Awesome. Okay, now let us move on to the next question. So the next question is saying, what is the molar mass of calcium sulfate? So you see here we're talking about elements, and now we are looking at compounds. So now we have this compound called calcium sulfate, which has this chemical formula. How would you calculate the molar mass? So let's go through that. So you'd say, okay, which question is question number 4? So you say, okay, question 4, it's fine. So first of all, you have to know what is the molar mass of the elements that constitute the compound. So you see, you have calcium, you have sulfur, you have oxygen, right? So you say, okay, molar mass of calcium. I'm just going to open a bracket, say Ca. Is, if you look at your periodic table, the value for the relative atomic mass, that's your molar mass. So you see it's 40,08 grams per mole. You can just write grams dot mole to the power of -1, it's fine. Now look at the molar mass of, what is this? Molar mass of sulfur, and then you say, okay, it's 32, 06 32,06 grams per mole. 36,06 grams per mole. And then let's check the molar mass. The values might slightly differ depending on the type of periodic table you are using, but always use the values provided at the back of your question paper, or sometimes the question itself will give you the molar mass. But in this case, just look at the value at the back of your question paper. So the molar mass of oxygen, according to the periodic table that I was using, will be 16. Some may say 16 point something, some round off, etc., etc. So you have 16.00 grams per mole, right? So now we have a compound here called calcium sulfate, and I'll say, okay, to find the molar mass of that compound, which is CaSO4, I will simply do this. So follow with me clearly. So I will say, okay, it's going to be equals to, what's the molar mass of calcium? It's 40. It's 40.08. It's 40.08 plus, now what's the molar mass of sulfur? It's 32.06. So we have put 32.06 plus, what's the molar mass of oxygen? Okay, I see there's oxygen, but there's 4 of them. It means that normally I like opening a bracket. Say, okay, it's 16. However, there's 4 oxygens there, and then I put the whole thing on my calculator to find out what it is. So it's an okay. Let's do that. So okay, you say, okay, I have 40.8 plus 32.06 plus, but now I open a bracket, it's 60 multiplied by 4, bracket closed, and you say, how much is that? And then you change here from the fraction to decimal by clicking that button, and you say, okay, I get a value of 136. And what's 136 point something? Let me check. 0.86 grams per mole. Always include the unit of measure, so it's going to be 136 per mole, right? So that is your final answer. So you just write there and say, therefore, the molar mass of calcium sulfate equals to 136 grams per mole. Okay, now we go to the next question. So in the next question, you said that what is the molar mass of sucrose, the type of sugar? That's sucrose. It's like, oh, okay, same thing that we did with this one. I'll check at the constituents of my sucrose. I see that it's made out of carbon, 12 carbons to be exact, 22 hydrogens, and 11 oxygens. So I start saying, okay, what is the molar mass of carbon? The molar mass of carbon, you know, it is 12. Grams per mole. And then you say, okay, what is the molar mass of hydrogen? Say, okay, the molar mass of hydrogen is gonna be 1,01 according to my periodic table. I hope you know by now where these values are coming from. How do we find the molar mass of elements? And then you say, okay, what is the molar mass of oxygen? You said it's 16. You say, okay, 16 still grams per mole. All right, so there you are. Then you will go down and say, okay, now to find the molar mass of this entire thing, my sugar there, sucrose, which they said it's C, what did I say? C12H22O11, C12H22O11. Then you say, okay, how much is that? Then you say, okay, it means that I'm gonna open a bracket and say, okay, we see the molar mass of carbon is 12, but how many carbons do you have? You see, because of the subscript, it's 12 as well, so it's 12 times 12. Then you're gonna say plus the molar mass of hydrogen is 1,01. And how many hydrogens? It's 22, so you multiply by 22. And then you open another bracket, then you say plus, that is the molar mass of oxygen is 60. How many oxygens do I have? I have 11, so it's 16 times 11. Right? Put that in the calculator as it is. I want to move this. Why doesn't it want to move? Okay. So you say, okay, I'm going to open a bracket and say 12 times 12 is 144. Okay, close bracket. Plus, open bracket, 1.01 multiply by 22. Open another bracket. Plus, bracket, you're saying 16 times 11. Then you close the bracket, then you find your answer. Then you say, oh, okay, the molar mass of this whole thing is actually just equals to, so I'm gonna write this neatly. So you say, okay, so the molar mass of C12H22 O O12 O11, I'm lying, equals to, what was the value that we found? It's a 342.22. So 342,22 measured in grams per mole. And that will be your answer, right? Okay, so let's look at another question. So okay, we are almost done. It says calculate the number of moles in 1 kg of magnesium chloride, right? So you say, okay, let me go down a bit. I'm gonna start this question over here. Magnesium chloride. You say, okay, they said they have the mass of it, which is small letter m, is 1 kg, but I know that I must convert that 1 kg to grams. So when you convert from kilograms to grams, it's just a matter of kilo means 1,000, so it's going to be 1 multiplied by 1,000 grams. Which is just going to be 1,000 grams, right? 1,000. It's a 0, it's not a 6. 1,000 grams. So you have the mass. It's magnesium chloride. How do we find the molar mass? We say, okay, the molar mass of magnesium chloride. So we now know how to calculate molar mass of compounds. So magnesium chloride is a compound. It's not just a single element. So you say, okay, I'll look at my periodic table and say, okay, the molar mass of magnesium is 24,31 plus the molar mass of chlorine is how much is that? 35,45, but there's two of them, so I must multiply by 2. And we say that thing is equals to, we put this, let's put this in the calculator. We'll say, okay, oh, it doesn't like moving this thing. Let's try this part. Come on. Okay, yeah, there we are. So okay, 24.31 plus, I'm gonna open a bracket, 35.45, right? Whatever, we multiply by 2, you say shift, and you say, oh, okay, there we are. And then it's gonna be 95.21 grams per mole. But we are actually not done. What is it that we have to calculate? We actually have to calculate the number of moles. So if I have mass and I have molar mass, I can calculate the number of moles easily. And you know the number of moles is just going to be equals to small letter. It's going to be small letter m multiplied by big letter M that we just calculated. So it's going to be 1,000. So that's 1,000 there. Multiply by 95.29. Just check this answer with me if it's correct. The value of it looks way too big, but I think it's correct. So if you put this in the calculator, let's do that. You can just say, okay, the answer that I got there multiply by 1,000. So that's going to give me 95,210 moles. Then you just write, therefore, the number of moles in 1 kg of magnesium chloride is 9,510. Okay, the last question. How many moles are present in 2,445 multiplied by 10 molecules of methane? So CH4 is an element called methane. Okay, so let us do that. So we'll say okay. Let's start it there. We'll say okay. 1 mole of whatever methane equals to 6.022 multiplied by 10 to the power of 23 atom molecules of methane. So now what they have given me is this number of molecules, and I have to find how many moles are those number of molecules. What was the value? They said it's 2.45 multiplied by 10 to the 23, right? And then we do the same thing that we've been doing. Let me check if it's 23. Yes, it is. We just cross multiply that by that, you have n multiply by 6,022 multiply by 10 to the power of 23, which is equals to, then it's just gonna be the one, this one here, multiply by 2,45, which is just 2,45 times 10 to the power of 23. Okay, then you say, okay, I want to make the number of moles the subject. You divide both sides by 6.022. So what you do on the left, you must also do on the right. Then after that, you literally find the number of moles for that methane element. So even on the other side of the equation, you divide by the same thing. So there you are. Multiply. Oh, that's a multiply. Doesn't look nice, but I hope you are able to follow with me. Divided by 10 to the power of 23. This is just going to divide that. You are left with n, and then just put this expression in the calculator. So if we do that, you will say okay, clear. Then you will say it's 2,45 multiplied by 10 to the power of 23, and then you'll have divided by 6.002 multiplied by, I don't know why I'm singing right now, getting a bit tired now. Okay, then you say how much is that, and then you change it to a decimal. You find that it is 0, so you see, you just round, we're gonna round it off here to 41, 0,41. If you're writing to 2 decimal places, it's gonna be 0,41 mole. All right, but are we done? I don't think so. It says how many. Oh, we are done. So you say therefore there is 0.41 mole of magnesium chloride in no, not magnesium chloride, of methane of CH4 in 2,45 times 10 to the power 23 molecules of CH4, and then you'll be done. Thank you so much for watching.